Okay, we have lesson 7-7 here, scale drawings, page 372 in the book. What is a scale drawing? Well, it is a two-dimensional drawing that accurately represents an object. It is also mathematically similar to the object. We remember the last lesson, similar meant that all the sides have to be proportional. Okay? So the scale is the ratio of the dimensions of the drawing to the dimensions of the object. And all dimensions are reduced or enlarged by this same scale. So you can't have the left-hand side of your drawing have a different scale than the right-hand side of your drawing there. Once you have the scale, everything goes by the same. And scales can be the same unit or different units. Examples, 1 to 20 means 1 unit on the drawing is 20 units in real life. And remember that the first number is going to always be the drawing. So 1 centimeter to 1 meter means 1 centimeter on the drawing is 1 meter in real life. 1/4 inch to 1 foot. 1/4 inch of the drawing is equal to 1 foot in real life. 1 inch to 1 millimeter. 1 inch on the drawing is 1 millimeter in the real life. Okay, and then this just says enlargement, but what I wanted to put there was we can have enlargements, preservations, or reductions. And I meant to put all three of them there. What that means is that depending on your scale factor, you may be have scaled up from the drawing to the original object, or you may have scaled down from the drawing to the original object. Okay, and then a special note, sometimes a scale may be stated as some measurement to 1 foot. When you have just the 1 foot or the 1 unit on the second part, you can sometimes abbreviate by just saying the first part. For example, 1/4 inch to 1 foot can be said to just be the 1/4 inch scale, or 1/2 foot inch on your drawing to 1 foot in real life can just be said to be the 1/2 inch scale. So first of all, let's use proportions to find the unknowns. We've done that before. So you got to figure out all the different things that you know about a project. So you read through the problem and you see that the object's length is 15 centimeters. The drawing has a length of 5 centimeters. And we have a scale of 1 centimeter to how many millimeters? Well, let's just find that scale. That's what they're asking for. So we set up the scale, 1 centimeter to X meters. We set up the two things we know here, the 5 centimeter, and that's from the drawing. Remember, the drawing goes on the top, and the real life length goes on the bottom. So 5 centimeters over 15. Then I cross multiply. 5 times X is 5X. 1 times 15 is 15. I then divide by 5, and I end up with 3. So my scale is 1 centimeter equals 3 meters. Okay? How about the second problem here? The object length is what they're asking us to find. They're telling us that the drawing's length is 3.5, and they're giving us a scale of 1 to 12. So we write our scale, 1 to 12. We write the drawing's length, 3.5. We write what we're looking for, which is the object's length, the actual length in real life. 3.5 times 12 is 42. 1 times X is X. So the actual length is 42 feet. Now let's take a look at, what if we're given another scale? We're going to set it up the same way. This time we're told that we still want to find the length. This time it's a paramecium. And if you remember from your science class, you can't see a paramecium. You have to get a microscope out. And in so we want to know how long in millimeters is the paramecium. Well, when we look at the paramecium in the microscope view, it's 39 millimeters. Let me draw that correctly. Millimeters. It's 39 millimeters long in the picture we got from our microscope. And we know the microscope has a scale of 1,000 to 1. So our drawing, or our original item, is proportion 1,000 over 1. We get that from right here. Then we have to say, well, what are we going to set up? 39, which is our original, our dilation view, and x, which is what we're looking for right here. So we cross multiply. 39 times 1 is 39. 1,000 times x is 1,000x. And we divide that out, and we get 0.039 millimeters. So the paramecium is actually 0.039 millimeters when we see it in our microscope as 39 millimeters. How about use the scale to find other unknowns? Well, once again, you're just going to use the scale as part of your proportion that you set up. So I have a drawing that has a wall height of 3 inches, and the actual wall height is some unknown amount. So we're going to find the actual wall height. And we're told we're in the 1/4 inch scale, which, if you remember, 1/4 inch to 1 foot. So I set up my proportion as 0.25, which is my 1/4 inch, okay, over 1 to 3 over x. 3 being my drawing's height. I cross multiply. 3 times 1 is 3. 2.5, or 0.25 x is the answer on that cross multiplication. Then I divide by 0.25 and I get a final answer of x. So the wall is 12 foot tall. And then finally, if I give a 3 inch, the only thing that's changed here will be between A and B. Between A, if I can get it to stop moving, between A and B is what? My scale height. Up here, it was a 1/4 inch scale, which meant it was 1/4 inch to 1 foot. Down here, it's 1/2 inch equal to 1 foot. So it's going to be a bigger drawing. It's going to be a smaller wall, excuse me, because we've increased the scale to mean 1/2 inch is 1 foot. So we set up our 1/2, which is 0.5, over 1, which is our 1 foot. That's coming from this guy right there. And we still have the same 3 and an unknown as we had up above. 3 times 1 is still 3. 0.5 times x is 0.5x. And when we divide both sides by 0.5, we find out that our wall is 6 feet tall. And that's how to use proportions and scales.